Welcome back. In this video, we're going to finish up chapter 2 finally by looking at solving linear inequalities. So to get started, we need to look at just what an inequality is and the relationship between graphs and interval notation, and then actually start working on the inequalities themselves. So first of all, as a reminder, the symbols for inequalities, as you know, an equal sign means two things are equal. If two numbers are not equal, then one is less and one's bigger. How you say that, there's a less than sign or greater than sign, and those two are used basically to express the same fact, but in two different ways. 5 is less than 8 means the same thing as 8 is bigger than 5. It just depends on which one maybe you want to emphasize. We also have an inclusive version that has or equal to in it. So the symbol x is less than or equal to 5 means that x could be any value that is smaller than 5 up to and including 5, but no more than 5. The other way, x is greater than or equal to 5 means that x could be any number 5 or higher. So one is called a strict inequality, whereas the other ones are not strict. So pay attention to whether or not the equal sign is included. Okay, so how graphs can look on the of inequalities on the number line. If we wanted to think about the solutions of x is less than or equal to -1, the graph would look like, well, it's the numbers from -1 to the left. Remember, the numbers that are less are to the left. So anything to the left of -1 would be in our graph. For the numbers greater than 2, that would be the numbers from 2 to the right. You'll notice in here that I've got a square bracket on the or equal to, the less than or equal to, and then on the one where it's strictly greater, a parenthesis. You'll find that that's always the case. We use square brackets when there's the or equal to case, parenthesis when it's not. For x less than 3, those would be the numbers smaller than 3 on the number line, so anything to the left of 3. And again, here I'm using a parenthesis because 3 itself is not included. And then let me do one more where we have the last possibility. Let's do another greater than or equal to. So let's make x is greater than or equal to 10. That would be the numbers 10 and higher. So anything to the right of 10 and also including 10. By the way, depending on where you went to school and when and what book you were using, you may have used graphs that looked a little different than this. If you learned this like I did, then you would have used a solid circle for the cases where the end was included instead of a square bracket. A solid circle was used, and where the endpoints were not included, an empty circle was used. These days, it's more common to use the square brackets and parentheses way of doing it. So just so that you know, it's common to use parentheses and brackets. Okay, and that's how you translate. Either way, solid circle or square bracket means that the endpoint's included. Parenthesis or hollow circle means that that endpoint is not included. Okay. So when we're talking about an inequality is going to have a whole interval of answers to it, and so we have a special notation for that. And that notation is called interval notation. We're going to look at it right now. So I've got 4 different possibilities here. X is less than 2, X is greater than 2, X is less than or equal to 2, and X is greater than or equal to 2. And so how we'll do the graphs for this, let's put the graphs up first. They're all relative to 2. I wanted to make that part the same. So X less than 2 will be a parenthesis. Sorry, my pen has stopped 1 second. All right, so we're back. Sorry about that. So for x less than 2, it'll be a round parenthesis and all the numbers to the left of 2. For x greater than 2, it'll be the numbers from 2 to the right. And here, notice again, we're using parentheses because they're strict inequalities. The 2 itself is not included. For x less than or equal to 2, it'll be the numbers from 2 to the left, and I've got a square bracket on the. For x greater than or equal to 2, square bracket on the 2, arrow going to the right. Okay, sorry about that. Zoom quit for a minute. All right, so we want to add to this the interval notation. Interval notation is a way of describing this chunk of the number line that we're interested in. So for this, first one, it would go down to negative infinity and go up to 2. So at the left end, we'll have a parenthesis, a negative infinity sign, and then a 2 and a right parenthesis. A parenthesis is always used with the infinity sign. You never use a square bracket with it. The left end of the number line is where negative infinity is. And so this would be the set of numbers from negative infinity up to 2. On the next part, we have 2 up to positive infinity. So at the left end, we'll have a parenthesis, a 2, a comma, and then the positive infinity sign. Here, the plus is optional. Okay, for x less than or equal to 2, then this will be the numbers from negative infinity up to and including 2. So again, we'll have a square bracket on the 2 side. And then lastly, for 2 up to positive infinity, square bracket, 2, comma, infinity. This square brackets and parentheses on the interval notation, I think, is why the square brackets and parentheses appear on the graphs, because they match up. Remember that the parenthesis stands for not included and the square bracket for included. And also remember that with the infinity sign, the parenthesis is always used. Another thing to remember with interval notation is that order matters. So you never want to write something like 2 comma negative infinity. Remember that in interval notation, the numbers always appear in the order that they're in on the number line. Okay, so that is interval notation. The part that we'll need at least for this section anyhow. Okay, so let's practice just a bit. We're going to write each of these inequalities using interval notation. So take a minute, pause the video, try this yourself, and then we'll go through it together. Okay, so here for y is less than or equal to negative 4. I'm going to make the picture also just because I'm here showing you. So negative 4, that would be the numbers to the left of negative 4. So we'll go from negative infinity up to and including negative 4. For t greater than 11, sorry about that. So we'll have 11 on the number line, and we want everything to the right of that. And a parenthesis because it's strictly greater. So this will be left parenthesis 11 up to infinity. Okay, for k bigger than 9, this will be the numbers that are bigger than 9. Actually, I already did one like that. So we should have, which version am I missing? We'll stick with it. For bigger than 9, it will be from 9 up to infinity. And lastly, for w is greater than or equal to 10, that will be 10 up to infinity. And the only difference is that we've got a square bracket on 10. All right. In the next set of examples, we're going the other way. We're to write each of these things from interval notation back to inequalities. And just for consistency's sake, we'll use x as the variable. All right. So the first one, we have the numbers from 16 up to positive infinity. So that will be x is greater than or equal to 16. Okay, negative infinity up to 5 will be the numbers less than or equal to 5. For 9 up to infinity, you could cheat and look above, I guess. This will be x is greater than 9. And lastly, negative infinity to negative 100. This is all the numbers that are below negative 100. So x is less than negative 100. All right, so this first part, we're reviewing or looking at interval notation to help us decide or describe solutions to inequalities. The next part we need to look at is what steps you actually take to solve an inequality. And as you recall, our first part of solving equations was looking at what you can do to an equation: add, subtract, multiply, and divide both sides of an equation by some number. We have a similar couple of rules for inequalities. The first one is going to be a subtraction and addition property of inequality. So that's shown here in purple. Let's take a look at that. It says for any numbers a, b, and c, if a is less than b, then a plus c is less than b plus c. Also, a minus c is less than b minus c. So we'd had a corresponding statement for equality. If you take all those less signs and turn them into equals, you get something familiar, right? The addition and subtraction properties are kind of common sense also, which is good. If you have two numbers in some order, if A is less than B, then adding the same amount to both preserves their order. Subtracting the same amount from both preserves their order. Okay? If you are younger than your brother, in 5 years, will you still be younger than your brother? Answer is yes. If you add 5 years to both of your ages, the younger one is still the younger one. Okay, suppose that you weigh less than your sister. Okay, if you weigh less than your sister and you both lose 10 pounds, then you still are going to weigh less than your sister because you've lost the same amount. That preserves the order. Okay, so let's try to apply this property. For this first one, it says solve p minus 2 is greater than or equal to 5. So we want to solve that using interval notation, or answer using interval notation. So if p minus 2 is greater than or equal to 5, we're going to add 2 to both sides. So p minus 2 plus 2 will be greater than or equal to 5 plus 2. I've added 2 to both sides. That will give us p is greater than or equal to 7. Okay, so our goal, just as with equations, is to get the variable by itself. Here we needed to add 2 to both sides to make that happen. Our answer in interval notation is 7 up to infinity with a square bracket on the 7 side. Okay, next we have p plus 8 is less than negative 10. And so in order to get the p alone, we should subtract 8 from both sides. So let's do that. P plus 8 minus 8 is just p. Negative 10 minus 8 is negative 18. So we have p is less than negative 18. So that's negative infinity up to negative 8.